its lecture. Today we shall discuss about Lagrange's mean value theorem. What is Lagrange's mean value theorem? Lagrange's mean value theorem states that if fx is a real valued function on unclosed interval AB, and if fx follows and fx satisfies number 1, fx is continuous on the closed interval AB, and second, fx is differentiable on the open interval AB. If this function of x satisfies both these two conditions, then we can write, then there exists a value c which belongs to AB such that a prime C, which is simply FB minus FA divided by B minus A. So this is the Lagrange's mean value theorem stated, that if function of x is a real valued function on this closed interval AB, and this fx is satisfied this two condition, that fx is continuous on the closed interval AB and this fx is differentiable on the open interval AB, then there exists a c which lies between AB, this closed interval, such that this formula holds that a prime c means ddc of fx, right? Or ddx of fx at the point x equals to c, which is equals to function value at point B minus this function value at point A divided by this simply B minus A, right? Now let us take the geometrical interpretation of this Lagrange's mean value theorem. Take this one is y-axis and this one is x-axis. So this one is x-axis and this one is y-axis. We know that y is equals to function of x, right? If this curve shows that y is equals to fx value, right? Take point, and this is the point A and this is the point B. If we take coordinate value of M, this is simply is 0. And this point as N, and if we take this, the coordinate of this N is B0, right? So what is the value of this point? This is function of A. And what is the value of this point? This is function of B. So what is the coordinate of A? From the graph we can write coordinate of A is simply A function of A, and coordinate of B is simply B function of B. Right? Now if we join this A and B, so AB is the chord for this curve, right? And if this chord makes an angle theta with x-axis, because this line is parallel to x-axis, so we can say that this chord makes an angle theta with the x-axis, right? Now if we draw a tangent at this point and take this point as C, right? This one is equals to simply C0. This one is equals to P. So this point P value, coordinate of P is simply C0, right? If this point is equals to C, look that these two lines are parallel, right? This chord AB and this tangent C is the parallel, right? So if we say that this angle is theta, so we can write this angle is also theta, because these are correspondence angle, right? Now if we, this one is equals to R. If we write this one is equals to R, so from the triangle ARB, what we can write? From ARB we can write tan theta is simply BR divided by AR, right? Now from the graph, what we can say? That AR is simply MN. From graph we can say AR is equals to MN, right? So we can write here that tan theta is equals to simply AR is equals to MN. So tan theta equals to BR divided by MN. Now look at this graph. What is BR? What is BR? If we take BR is equals to simply BN VN minus of this RN. If we take minus of this RN, so we can take these values BR. So we can write BR is equals to Bn minus Rn, right? And what is the value of Mn? Mn is simply, if this one is origin O, so On minus Om, right? On minus Om. Now what is the value of Bn? This is simply Fb, right? So this one is tan theta Fb. What is the value of Rn? Rn is simply An. So we can write Rn is equals to Am. What is the value of Am? This is simply minus Fa, right? Now what is the value of On here? On is simply B divided by B minus what is the value of Om? Is equals to A. Now we can say that tan theta is equals to Fb minus Fa divided by B minus A. Now take a look at this graph. What is tan theta? If this one is the tangent at that point C, this one is the tangent at the point C, and if this angle is the theta, so we can write tan theta is simply the slope of tangent at point C. Now what is the slope of tangent at point C? From the differentiation we can write tan theta is equals to A prime C, right? Because slope of the tangent at point C is simply A prime C. So we can write tan theta is equals to A prime C. Using this here, A prime C is equals to Fb minus Fa divided by B minus A. This is the Lagrange's mean value theorem, where C is lies within A and B, right? So thus we arrive the geometrical interpretation of mean value theorem. Now to understand this concept very clearly, let us take an example. Verify the Lagrange's mean value theorem for Fx is equals to x into x minus 2 on this in closed interval 1, 3, right? So to solve this problem, now first take a look at this example. We have to say that verify the Lagrange's mean value theorem for this function Fx equals to x into x minus 2 on this closed interval 1, 3, right? Now to solve this problem, what we can do? First we say that Fx is equals to x into x minus 2. So Fx is equals to x square minus 2x. Since this Fx is a polynomial, So from the polynomial property we can say that this is continuous and differentiable also everywhere. So this is continuous and differentiable everywhere. Right? So we can say that this fx is continuous on this interval 1, 3, right? And fx is differentiable on this open interval 1, 3. So this function satisfies both these two conditions. Right? So from Lagrange's mean value theorem, we can say that there exists a C lies between AB. Here, write B is equals to 3 and A is equals to 1. Right? So we can say that here there exists a C which is lies within 1 to 3. For this expression satisfies. So we can say that there exists a C. We have to check that if this C lies between 1 to 3, right? To verify this Lagrange's mean value theorem, we have to show that there exists a number. For this formula is satisfied. But if this C lies within 1 to 3, right? So we can write there exists a C. C, right? For this, what is f prime C? We have to find out these values, f prime C. If fx is equals to x square minus 2x, f prime x is simply 2x minus 2. So what is the value of f prime C? Prime C is simply 2c minus 2. Right? Now, f prime C is equals to fb minus fa by b minus a. So here b is equals to 3 and a equals to 1. So what is the value of f3? f3 is simply 3 square minus 2 into 3, which is equals to 9 minus 6 equals to 3. And what is the value of f1? Which is equals to 1 square minus 2 into 1, which is equals to 1 minus 2. This is simply minus 1. So we can write 2c minus 2 is simply 3 minus of minus 1 divided by 3 minus 1 from this expression. Here f prime C is this one, f prime C, which is equals to FB is F3 is equals to 3 minus of FA equals to minus 1 minus of minus 1 divided by B minus A. B is equals to 3 and A equals to 1. So this expression comes out 2 multiplied by C minus 1, which is equals to 3 plus 1 divided by 2. So C minus, from this we can write C minus 1 is equals to 4 divided by 4 is simply 1. So the value of C is equals to 1 plus 1 is equals to 2. So we can say that C is equals to 2. So here we see that 2 lies within 1, 2, 3. Right? So we can say there exists C is equals to 2, which lies within 1, 2, 3, such that F prime C is equals to FB minus FA divided by B minus A. This equation hold, right? So this is all about the Lagrange's mean value theorem, right? Thank you.